Hello, everyone. Good morning, good afternoon, good evening. Thank you for joining us today in our webinar on VoLTE, a very exciting and crucial topic for the telecom industry. And I know I'm not going to take much of your time. I'll be starting soon. But before that, a little bit of points that I want y'all to remember just to make this whole experience seamless and exciting as well. So, point number one, I'm your host, Sonali. I'm going to be there through this session. And during the course of this discussion and webinar, if you all come across any kind of a glitch, you have a question, or you want to know something more, I'm right here. You can ping your query or your question in the chat window, and I'll be there to help you. Point two, going ahead, there's going to be a Q&A session, which we have parked at the last of our session. But we've seen that it always helps if you have questions while Sergey and Milan are discussing points. You can post them. You can post them in the chat window. And what will happen by that? We will have more questions, more time to address your queries. So we can try and get as many questions of yours answered in the 1 hour time window that we have. Third, and the most important one, ladies and gentlemen, we're going to share a recording of this webinar video with you after the presentation. So you will have it with that. You can share it, watch it, and also raise the questions after the webinar is over. And now that we're all set, I will not take much of your time, but call on my expert team, Sergey Marshiko, a telecom security research expert, and Milan Reseda. Both of you all will walk you to the presentation on VoLTE. Over to you guys.
Sure. Thank you, Sonali. So, as Sonali said, my name is Sergey Mshkov. I am really interested in IMS security and also diameter security. That's what I do. So today we'll talk about VoLTE, a little bit about how we got there, about history of the technology, about current situation. We will see what problems do we see in real networks. And we will see short takeaways in the form of recommendations to MNOs. So how the problems that we've seen can be dealt with. So VoLTE. But before we even start talking about VoLTE, we need to understand what IP telephony is. IP telephony, or which is commonly known as VoIP, Voice over IP, was introduced in 1995. It was a big success. It was really convenient for businesses, and it spread rapidly by the early 2000s. By 2003, about 25% of all voice calls were made using Voice over IP. And as with all successful technologies, there was quite a large interest from manufacturers. So bad things happened. Like it was possible to break into companies' telephony system, call personnel, maybe even intercept calls or listen on the room devices, things like that, right? But good part is that this allowed technology to mature. A lot of problems were fixed, and fix came in the form of SBC, session border controllers, specific nodes that monitor traffic that is coming either from subscribers, like here, Access SBC handles traffic from users from phones in VoIP case. And also Interconnect SBC, which handles interconnects to other providers of telephony. You can also see there that there is SIP signaling and RTP media, two main protocols that are used for VoIP. We'll talk a little bit about them later, and we'll talk about problems uniquely related to SIP. So it was quite good for businesses, but this technology had no use in mobile networks at all. Well, it had no use until 4G LTE was created. You see, 4G LTE is all IP network. First all IP network for mobile networks, for mobile. And as such, VoIP seemed to be a really good fit. Again, all IP network, right? So Voice over LTE was born. Voice over LTE is just a name of technology, how it is implemented specifically for mobile networks. Still VoIP with SIP and RTP. Here on the picture, you can see a usual mess of interfaces that you see when you open specifications, a lot of boxes, a lot of connections, some gateways. So let's dive into the history of VoLTE or other mobile networks to see why some of these boxes are needed in the first place.
Let me pause you for a moment.
Yes.
I hope so far the intro was great and everyone understands. Just out of curiosity, how is the voice quality? I read somewhere that in areas with let's say poor LTE coverage, the user experience might be worse than when using the CS. What's your opinion here?
Okay, you're asking two different questions here. First, VoLTE as voice over IP as a solution for voice is better in terms of quality. Better codecs are used. Yet there may be problems with user experience, as you said, because for VoLTE to even work, you need 4G cells. We'll see in just a moment how it happens and how networks trying to combat this.
Super, thank you.
So 2G voice, a start of mobile networks as we know them right now. It has own core which handles signaling. So let's start from the other side. There are mobiles, right? Devices of subscribers. Those are connected to cells. Then some boxes connected to the cells for it to work. Then onto the circuit switch core, which has nodes that control mobility of subscribers. HLR node, which is a server that stores all information about subscriber, where this subscriber is registered, keys, etc., is also there in the core. And also gateways in case subscribers need to call landline, for example. We also may point out that it's already not voice only since SMS center is here. So it is possible to send short messages. But it's not quite the internet data, which was introduced later in the form of packet switch core with two new nodes, SGSN and GGSN, that provided just this access to the new network, internet. Then there was more subscribers in the network, and due to this, 3G and updated radio was introduced. Still, the same network core was used, and this brings us to 4G, where this VoLTE we are discussing really was introduced. So for 4G, new evolved packet core was created. So subscriber traffic that goes to internet, subscriber data goes through server and then packet gateways. HLR was renamed to HSS, but it's usually the same node under the hood, so it's collocated HSS HLR. But if we look at this picture, there is no voice and there is no connection to all the networks. So how is this fixed? This fixed by introducing IP multimedia subsystem, which is the way to provide this technology, VoLTE, that we are talking about. So that's quite good solution. And as Milan asked, what is user experience? And user experience is different depending on which cells are available. You see, it's not possible to roll out 4G nodes all through the country overnight. It's really expensive and it's really hard to do. And this means that you have patchy coverage of 4G versus 3G and 2G. And this means that if you somehow disable all the ways to call, VoLTE won't work since there will be no 4G cell and no access to updated core. So to handle this, CS fallback technology was introduced. The idea here is that a subscriber device connects to cell in 4G and also in 3G and also registers in both technologies. So this way, call may be handled by VoLTE if needed, but if there's no 4G connectivity, the subscriber can quickly switch. And also, it can work in another way. Operator may not implement IP multimedia subsystem at all, but still provide 4G, since there was a lot of demand for data. 4G was in demand. VoLTE not so much. We'll talk about this later, I think. So if subscriber needed to call, subscriber just dropped to 3G or 2G and performed the call as needed and then reconnected to 4G for data. So that's it for 4G, but we also have 5G now. And two flavors at that, 5G NSA, in which case it's just new radio with old core, as we've seen earlier. Same, VoLTE. And also 5G SA standalone. New 5G core is used here, but still we see this UPF to IP multimedia subsystem connection. It is called differently. It's called voice over new radio because that's what it is, new radio. But at the heart of it, it's still IMS subsystem with all its quirks. Of course, there is fallback for NSA, which is basically the same, and for 5G SA, which works in a similar way. So, fallback. This means that operators may provide data, which is indeed in high demand, but may disregard at all any implementation of IMS. And actually, that's not what happened. Indeed, CS fallback killed all the interests among MNOs to deploy full operational MS core because it's a lot of capital expenditure, a lot of nodes bought specifically for MS. Still, they were ready. They tried pilot projects, etc., etc., etc. Still, usually subscribers are not really keen, are not really interested, because for subscriber, there are two distinct things that are interesting. First, you may have better quality of the call, which wasn't really interesting for a lot of people. Calls were fine as it were. And also no switch between 4G to 3G for data, which also wasn't that big of a problem for most of the subscribers. So let's see how this actually was introduced. If we check the time, you see first LTE network, December 2009 in Sweden and Norway. So that's just LTE data. And then 3 years later, whole 3 years later, VoLTE network, now with voice, with support of only one phone, LG Connect 4G, right? And what's interesting here is that wasn't a full-featured VoLTE network. Full-feature one was deployed in Singapore 5 years after first deployment of LTE. So we clearly see that operators are not really interested. And again, only one phone. Sure.
Yeah, Sergey, I must stop you because I guess everyone might be asking. You partially answered on the previous slide, but still, from today's perspective, why did LTE implementation take so much time?
Yeah, two things. First, you need to have ability to do so, to switch to VoLTE. And you see that if only one phone supports this, it's really hard to switch to VoLTE. And second, lack of any push from subscribers or from operators. Let me go to the next slide. It also talks about that. So first of all, only in 2020, it became commonplace for most new phones to support VoLTE. So 10 years before it was production ready from the point of MNO. And from operator standpoint, there was another type of interest, another drive to use VoLTE is, and that's the idea that 2G and 3G may be removed to reuse the frequency for 4G and 5G. So it was interesting for operators. It happened in Asia for certain countries, but in general, it wasn't that hot for operators. So to repeat, subscribers and operators not interested, and also devices lagged behind. Chicken and egg problem, really. Okay, so that was just like this, just like I described, until December of 2022. With USI Verizon shutting down the 2G and 3G networks, operators understood they have a problem on their hands. You see, USA is a really lucrative spot for people to go to, right? Really lucrative destination. So operators all across the globe want their subscribers to roam freely in the network. But if 2G and 3G and CS fallback as such are not working, they have to support a new technology now. Well, new to them. And this all turned into a race for VoLTE deployments in 2023. Some operators implemented VoLTE in a few months. It was really quick. Good thing that by that point, since technology was rather old in specification regards, GSMA prepared security documents. GSMA FS22 VoLTE security analysis and recommendations, and also GSMA FS38 SIP network security, which is relevant since SIP is used all over the VoLTE technology. So let's see how all of these maps the real world scenario. Let's see what we saw in operators after this point. But first, a few words on how it is possible to get into the network. We need to understand that IMS is a separate network as is internet, right? And each of these networks has its own name. APN, access point name, is just a name, a way to connect to a specific network. And APNs have types. For IMS, it's IMS. But there is also default type. And if you check on your phone, you can, on certain phones, you can see it, on certain you can't, but still, you will see IMS APN. And if you change it to default from IMS, it will be used as phone is connecting. But you see, in 4G, phones are not only devices that are used. It is also possible to use 4G dongles or other devices. And 4G dongle may be reconfigured to use this IMS APN as a default one. And not surprisingly, this results in connection through packet gateway to IMS. And this may allow malefactors to reach into the network, into the IMS network. So as I said, packet gateway, IMS APN, and the whole network behind this name, behind this APN. But what I want you to understand is that there are actually several technologies that all share the same idea, connection to the IMS subsystem. This is VoLTE, voice over Wi-Fi, where connection and authentication is done differently, but then goal is still to get into the evolved packet core through packet gateway to the networks, and one of the networks available is IMS. And voice over new radio in 5G standalone uses UPF, but idea is the same, APN into the IMS network. So different technologies, still the same culprit, the same system under test, IMS. So, as I said, usually here on the left, we will see subscriber's phone. Here on the right, we will see PCSCF. So the node that controls incoming traffic into the IMS subsystem. First question, do we see something else? And yes, we do. It means that malefactors can scan the networks, can find other hosts, and these hosts may be hacked, since you can see that sometimes things like SSH are available to the phone, to the connection from the phone. Of course, there may be protection measures. So here you can see that user has been logged and you can't log on it for admin account. So it wasn't possible to perform a lot of tries. Still, it's although it's just a minor inconvenience, it still may be used to somehow affect the nodes in the IMS subsystem, or even operator core, since you can't be 100% sure what is available here. It is quite common in IMS deployments. I should point out that hacked PCSCF may open a path into signaling network, since it also talks not just SIP, but diameter, and diameter messages may be sent through the signaling network to other operators. So here we have connection that presumably comes from the phone, but in practice it may be malefactor's laptop, 4G dongle. It comes to packet PCSF. And after that, after this node is hacked, other MNOs all across the globe may be attacked on behalf of the MNO being hacked. And general takeaway here is simple. MNOs should limit the number of nodes accessible via this IMS APN. And in general, it's a good idea to block everything apart from SIP and RTP ports on the nodes that have to be here. For example, if they handle audio calls themselves. Okay, it is possible to reach nodes here, but is it possible to reach other subscribers? And indeed, in some of the tested MNOs, it is possible. So here we used Netcat to send a message, and this message was received by the phone, which means that malefactors can try using this as short message service without paying for the connection, since data on this signaling connection is usually unbilled, or is built quite cheaply. So as I said, this may allow manufacturer to avoid any charging, and MNOs should simply separate IP networks for subscribers. We've seen that it is possible, so it really depends on MNO. I should point out that attack itself is a little bit tricky, so sometimes it may not work as expected, depending on how these phones are connected into IMS, but still it is a problem. Next step. Okay, it is possible to reach nodes, it is possible to reach subscribers, but can manufacturer impersonate other hosts? And indeed, it is possible. So here we have sent ICMP messages with this IPv6 address clearly saying that beef, and messages were received. It's not that big of an issue on real network because most important messages are going through SIP, and there is some kind of protection of authentication or encryption. Well, at least authentication, but we will see in just a moment that some of the messages may be sent without it. And it's still a problem that it is possible to send messages impersonating other hosts. Same recommendation to employ separate IP networks. If it's clear who PCSF is talking to, there should be no problem with impersonation, at least on IP level. So all of that was connected to IP, to just the fact that manufacturer can go into the network and try to do something. But meaningful data here is signaling via session initiation protocol, SIP, and data which is transferred via real-time transfer protocol. So SIP, as name suggests, is used to set up sessions. Sessions may be calls, video calls, etc., things like that. And SDP protocol is carried inside SIP to confirm capabilities of all the hosts. So here SDP went from phone to MNO, and in some of the messages went back, or rather MNO's SDP went back, confirming that the second leg of a call can use this specific technology, this specific codecs, etc. Once this is established, call is successfully established, and RTP is used to send data, be it voice, video, etc. So that's the general idea. But before you can even use SIP, you need to register. Here, specifically in 3GPP case, it goes like that. SIP register is answered by 4.1 unauthorized, which contains a challenge to this SIP register using key material that is stored both on HSS that we mentioned previously, a central server, and on subscriber's SIM card. So the next SIP register is actually answering this challenge, and if everything is okay, 2000 okay is returned from the network. SIP subscribe may be sent, etc., etc., etc. What I should point out here is that usually encryption, specifically IPsec, should be used from the second register. So 4.1 will, 4.1 unauthorized, will have information element clearly stating that encapsulated security payloads have to be used, and specific encryption protocol has to be used, right? And here we see that in a lot of cases, if initial register contained only one algorithm, specifically null encryption algorithm, networks will say okay and will continue using it, which means that there is no actual encryption. So this means that if malefactor somehow can get into the network, can listen to what is happening on one of the nodes in the network through which SIP traffic is coming, this malefactor will be able to see messages in the clear despite this encryption devices, encapsulated security payloads being used. I understand that's a lot of privilege for malefactor to misuse that, but it's still a problem. Another issue connected with that is that sometimes messages like options may also be answered before encryption will take place or before even before registration happens. So here we see 2000 OK from the network without any encryption, and even after the registration, 2000 OK may be sent.
Sorry to interrupt you, Sergey.
Yes.
I think the last 10, maybe more slides were so interesting, and you went through it pretty fast. So I really need to wait till Sonali shares the record of this call just to give it a try on my phone. So definitely it's pretty severe. However, my question goes to the encryption, because when I see encryption, the word itself, it always reminds me the zero trust of the 5G networks. However, we know the drawbacks of this. Based on your experience, what is the ratio of the networks using the encryption versus those not using it, and why it is the case?
Yeah, I got it. Interesting question, specifically because encryption here may mean two things. You see, in theory, encryption is used. You see here, now encryption is used, but it's no actual encryption. So we see that as a problem. And that's first part. But the second part is why this is happening. And, well, let me show you. Takeaways I've prepared for this is use strong ciphers like AES or SHA, and that's sensible, right? But in many cases, it is not possible for operators to use these ciphers, and they have to use null encryption simply because legislature in the country, so governing bodies come to them and say, we need to see what is happening with the traffic. Please don't encrypt it. And
simply
they
big
have
brother,
to.
big brother.
Big brother, yes. So this means that we still recommend this step, use AES or SHA, but sometimes operators cannot do that, unfortunately. And another recommendation is, of course, to allow only SIP register messages to be sent without encryption, which is self-explanatory. Okay, a big block of rather small issues, all connected by the same theme, information disclosure. Here's one of the examples. So when call is set up, SIP invite is sent, and 183 session progress is usually sent back from the phone dealing with the call. But this 183 session progress will contain some data, at least when it's coming from this phone. Then what we see is that MNO nodes won't strip that data. As I said previously, as there are SBCs, and I believe all MNOs all across the globe already have SBCs installed for VoLTE and for VoIP, just common sense. But those SBCs may not be configured correctly. And here, what we see, just one example, 183 with some data, like here, server, Xiaomi, etc., etc., etc. So we see very what a specific phone caller or callee is using in this case. And this means that malefactors may misuse this information to set up vendor-specific attacks. So phone model, right? Another option, if SIP invite is coming towards you when you are being called. Again, user agent, here we can see Samsung phone. Another option, another information disclosure is disclosure of FQDNs, of host names, which may be used by malefactor when they're trying as a way to hack the network, not from the VoLTE VoIP side, but from trying to hack infrastructure from usual ways or from internet. This might be interesting for malefactor, but also it allows malefactor to understand what kind of node it is. So it's pretty clear that this node functions as SCSCF, right? And sometimes it is possible not only get that it is SCSF, but also to understand which vendor it is. So here, option messages are sent before sending invites in the call as part of this pre-paging procedure by Huawei, and those may be misused again by malefactors because now they know that this network uses Huawei, and there might be some specific vulnerabilities that might be misused against this specific vendor. Another example, cell ID disclosure. So PXS network info PANI header can have cell identity, and sometimes this information isn't stripped, and this allows for location tracking for malefactors. Sorry. So another option or another interesting thing is a service which operators provide, which allows to call from anonymous number. For callee, it looks like it is not clear who is calling. Instead of number, there is anonymous or some gibberish, and this is sold separately by a lot of operators, right? But we see that information that is shown is connected to contact. Here, there was IP address here with a port, and it is different from the from. And surprisingly, we see correct telephone number here in the from. So in theory, malefactor may use this to still understand who is calling, and specific application may be created to combat this kind of anonymity, basically rendering operator service not working. So what are takeaways for all these things connected to data disclosure? Operators already have SBCs. They just need to configure them properly to remove unnecessary subscriber-related data like models, cell IDs, sometimes IPs, and also employ topology hiding on the same nodes, which will allow to hide what kind of node it is and its proper name. Next, as we just said, all these things are common sense in VoIP, right? Another thing that is common sense in VoIP is blocking a large number of SIP invites or other SIP messages coming your way, which is colloquially known as SIP flood. So what we've seen is that indeed it is possible to send a lot of invites, but usually it is not possible to overload hardware. It's no surprise. Yet this opens a way two other attacks. One of them is called silent call attack. Why is it called like that? Well, first we need to understand that when phone receives any message, it uses battery, right? The phone's modem uses battery. So if messages come in non-stop, as we can see here, so here you can see that invite is coming, phone has to send 133, those are not confirmed, etc., 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 etc. Then new invite comes, modem does a lot of work, and it never goes to idle mode. So battery is drained. And that's one part of it. The second part of it is if call setup procedure is unfinished, phone won't start ringing. And such invite also won't be built. So we can see here that in this specific case, a handful of calls went through and were visible on the phone. In other networks, it's not possible to see anything at all. A lot of invites are sent from one side, a lot less are received by the other side, but still modem is chugging along and battery will be drained eventually. And another problem, which is also connected with this SIP flood, specifically SIP flood of messages with unfinished invite procedure, is that phone may become stuck in handling this SIP invite. And here you can see that one of the subscribers tried to call, first invite, call went through. Then we started the test. And during this test, we tried to send messages. As you have seen, a lot of invites. And all the time during this test, for quite considerable amount of time, it wasn't possible for invite to even reach subscriber's phone. When we stopped the test, calls started working again. So this works as denial of service for incoming calls. What are takeaways? Again, use USB-C and enable protection.
Sergey, allow me to pause you one more time. From tone of your voice, I can see that probably this is your own research, right? So really, really pretty cool. I hope everyone on this call agrees that flooding might be easier to perform and harder to protect against, right? Do you think that this functionality you just mentioned is robust enough, or should MNOs consider any additional measure on top of it?
Yes, I do think so. 2 points here. Point number one, we see it working quite good in VoIP. So it is possible to basically block subscribers that is performing all these invites for some amount of time to shut down and stop processing invites. And this works quite well. That's point number one. And point number two is that we've seen networks that implemented it in a similar fashion, and they were protected from all the attacks I've described previously that are connected to SIP flood.
Super.
So
Thank you.
This is
Thank you. I see you got a lot of questions still now, so I'll pause and let you finish this.
Thank you. I've said a minute ago that SIP invite will be unbuilt if call setup procedure will never be finished, right? So what if this SIP invite will have some additional header, some additional part of the message? Is it really possible to send the message all through the network to other phone? And if it is possible, can manufacturer really set up a short message service where one message goes from A to B, then invite is dropped or cancelled, and B to A answers in new invite? And what we've seen, the answer is yes. we used this X header, and it went all through the network and allowed exchanging short messages, right? This is most probably due to the fact that if you read SIP 3261, RFC 3261, you will see that headers that are not understood but are not really important to processing the message should be ignored in most cases. And well, that's what we see. What is a takeaway? What is the way, a means to protect? It's the idea that SBCs on the network border may be available to remove all unnecessary headers, since it should be pretty clear which messages with which headers may be used by phones connecting to the network. So I believe that's the last one, and it is connected to SMS. There are many ways to send SMS. One of them is using SIP messages. So using SIP message in VoLTE, indeed, it is possible to send SMS. Quite, well, all trusty, I would say, encoding is used here. I should point out that there are two different kinds of SMS, and in this particular network, it was possible to send MT, mobile terminated SMS, which goes from network to MS. Why? I don't know. But SMS like that allow setting originating address. And here you can see that contact from is this 2390 guy. And originating address is different. And that is indeed what is seen on the phone. So this test SMS was received. It still contained from 2390. But since SMSs are passed differently, this originating address was believed and was used by the phone. So it is possible to impersonate other subscribers when sending SMS messages. Takeaway is quite similar to previous one. We really believe that most operators should have ways to protect the network already in place. They just need to be configured correctly. Here, SMSs are often screened for spoofing. And also, these SMSs or other SIP messages may be screened on SBCs because, again, I don't know why a phone should send network to mobile station empty SMS. This shouldn't happen, but was allowed. Again, most probably due to lack of configuration. Which brings us to general slide on recommendations. And we really believe in this process. 3 parts. First, you assess current situation. Then you enable protection and implement monitoring, which should be possible to do without any capital expenditure, because we believe in most cases all the needed nodes are already installed. They just need to configure it properly and tuned. And then, of course, perform periodical reassessments, because it's quite often that something changes in the network. It wasn't accounted for, and it opens a problem on security perimeter. I should also point out that IMS is future. 5G uses IMS, as we have seen. So VoLTE and all connected technologies like VoLTE An are the same, still IMS, are here to stay and should be protected. Now is the time. Now is good opportunity to address the legacy security issues of VoLTE, of VoIP, which are known for quite a while, since VoIP is quite old technology, like 30 years. Yet it is somehow new to mobile networks. And, well, as I said, now it's time to fix this. Most operators should be able to do so. Thank you very much. Please ask your questions.
All right. Thank you so much, Sergey. Thank you, audience. I'm Milan. Thank you for expanding on some topics and helping us understand the crucial deep tech VoLTE topics. But Sergey, we've filtered questions, quite a lot of them, and I will start posing them and you can help us with your answers. The question number one is, in VoLTE security, issues are only related to SIP protocol. Is that correct?
No. As I said, VoLTE is a way to connect to IMS network. And of course, SIP messages are going from point to point there, but the SIP messages go on top of IP. And there is a whole slew of IP issues that we've already discussed previously. So everything up to this point was connected to IP. It may not be SIP for it to work. Let me put it like that.
Okay. All right, Sergey. The next question is, what do you think 2G GSM will completely be finished and there will be only 4G or VoLTE in the world in the future? What are your thoughts on this?
Yes, that's a good question. I don't know for sure, but indeed it goes this way. As I said, this slide, there is a driving force for operators to somehow have more capacity in the frequency spectrum department. So 2G and 3G need support. You need to work on cells, on equipment. You need to support core in data centers. You need engineers to work on that. And since more and more machine-to-machine interfaces are using 4G and 5G, it becomes clear that there will be more push to get more spectrum. And at some point, I think it will be easier for operators to discontinue 2G and 3G. Question is when this point will happen, and will we even see it during our lives?
I would only add that refarming is in progress, right? Both 900 and 1800 are simply replaced or simply replaced by 4G in the suburbs. So we see the tendency to refarm these frequencies. But yeah, as Sergey said, you never know how much time it takes till everything will be, let's say, completed.
Yes, you also should understand that in rural areas, maybe there are not enough push to update, but at some point, costs of infrastructure will kick in, and it will be easier to just add one 5G node specifically set up for specific spectrum and to allow access there.
Good perspective, Sergey and Milan. But yes, we have another question coming. And this one is, how can we detect any dongle is trying to connect with the network by changing the APN to IMS for malicious activity? What could be condition at high level?
That's an interesting question. Well, my first reaction would be to try and somehow detect if DNS-like traffic, things like things connected to browsers, resolving addresses, etc., are somehow in the IP connection when it starts, because that's what we usually see when we are connected this way, which is uniquely different from the phones. But it's really a hard question, so I'm not sure how this should be done properly.
But this might be a homework for everyone here, right? different countries. Let's try, give it a try, and write us how it works.
Yep.
Okay. Another one, Sergey. There are quite a bunch of them. What type of attacks are most commonly observed in an operator's live network?
That's a very broad question. For VoLTE, it's really hard to answer because, to be honest, specifically these vectors that we have discussing from subscribers to the network core isn't looked much or isn't looked at all. So I'm pretty sure there are no equipment which monitors something like attacks from this vector. And that's why we are talking about this regard. It seems that for a lot of operators, VoIP or as VoLTE, Wi-Fi is a bunch of technologies that just work. They protect their interconnects towards other operators, but somehow this one eluded a lot of operators, and they just don't believe that anything bad really can happen from subscriber side. Or, well, there are several attacks connected to GTP broadly, which can be misused, but those are blocked, and that's it.
Okay.
So again, it's really hard to answer the question on which are happening most often because we don't have statistics, and I highly doubt that a lot of operators have the statistics in the first place.
Maybe the next question is better because the question is about what type of attacks has the most significant impact on operators. So maybe this is the one when you can simply elaborate more.
Yeah. Well, as I said, it's a little bit of theoretical thing. In theory, of course, attacking operator nodes and bringing down service is really important. You see, VoLTE is this weird state right now where CS fallback is still working in a lot of countries. So it's not a problem if VoLTE or 4G altogether stops working. It's fine. 2G and 3G networks will work on this. And it isn't as bad. But that's what we see right now. In future, the same attacks will have much higher impact since no CS fallback, no 2G, no 3G to fallback to. As such, attacks that target network equipment may be really important. Another option is attacks that allow malefactor to somehow hack the nodes, like here, using SSH. And then continue into the core, because if something like that isn't seen, if something like that is stealthy, this may lead to a serious compromise for operator.
Sure. Sergey, one more question, and this one is, why is authentication used in IPsec while encryption is set to none?
Could you please repeat?
Sure.
Please?
Why is authentication used in IPsec while encryption is set to null?
Yeah, you see, it's more of the way it works at all regarding authentication. So now encryption means that encryption is not happening, right? But it still means that all other parts of the IPsec suite are doing their part. So message itself, like seed message, for example, will be inside of encapsulated security payload container. So this containerization will still happen. And as such, since to set up this IPsec connection, there's still need to use keying material from HSS and from SIM, as I said previously. It is really hard for manufacturers to be in the middle. Like we show here, it is possible to send messages, but those won't be just IP messages or just SIP messages in IP, like IP UDP SIP as it usually is. No, it will be IP, then encapsulated security payload in which there will be UDP and SIP. And to generate correct encapsulated security payload, you need to have keys. So this works to authenticate connection.
Thank you, Sergey. Given the time, I will try and squeeze in 2 last questions.
Okay.
Thank you, audience, for your patience. So the question is, what are the key challenges of implementing VoLTE in ORAN, especially in a multi-vendor environment? Or should we consider ORAN a low priority for MNOs at this stage?
That is really hard question for me to answer. Personally, I am not quite sure that I know about any challenges connected to ORAN. Maybe Milan can help me with this. Certainly, I don't see it. As I said previously, we have several different technologies, different connection, different radios. But from the VoLTE perspective, it's the same. It's IMS multimedia subsystem, which is reached somehow. If you have internet, you have packet gateway or UPF or something like that. And it's not about radio in case of VoLTE. It's about connection to this subsystem instead of internet into IMS. So, as I said earlier, I'm not quite sure that I'm aware about any specific challenges.
Milan, anything that you may want to add?
Honestly, I'm not expert in this field. I would say that we might simply name few, let's say, generic topics like interoperability or quality of service. Might be also network slicing, right? But probably not. I'm not the expert on this.
All right, we'll try to get more practical answers to this in an offline manner. But yes, we have another question, Sergey Milan, the last one for today. And the question is there any possibility to block SIP invite alerts based on specific behaviors or patterns?
Based on specific behaviors or patterns. Yes, I think it may be possible to block on specific behaviors and patterns. Well, the blocking kind I described earlier is already checking the behavior. It's really strange for single subscriber to generate a lot of invites, since a single device usually can be in one call. That's normal. Of course, there are many cases where it might be not as simple. But if we are talking hundreds of invites from the same source, it's pretty clear it's rather strange, especially if those invites are not followed by any other processing. So things like that are already blocked by VoIP switches when they're configured correctly. And idea is to give a ban to this specific subscriber. As we've seen previously, to even send SIP invite, manufacturer needs to register. To register, this manufacturer needs to have a SIM or at least be able to generate needed keys from the key in the SIM card, which means that manufacturer cannot switch subscribers as easily. and ban for a single subscriber will work fine. In practice, it looks like SIP invites are not answered, are not acknowledged by the network, and are not, crucially, are not transferred to second part of the call, second leg. So what we saw there when invites keep coming is a problem of the nodes in between, which allow for that, which don't react by creating a ban for this specific subscriber. In the networks where it was not possible, and it was clear that invites were not coming for quite a long period of time. So this behavior was detected, and I don't remember the last time. It was like 20 minutes or so. I'm not quite sure regarding the timers themselves, but invites from this side, from this malicious actor, were not coming towards callee. So this already works this way. And yeah, that's a good idea.
Okay. Thank you, Sergey. Thank you for addressing all the questions. And I guess here we come to the end of the webinar. Thank you, everyone, ladies and gentlemen, for taking the time and joining us today, and also sharing exciting questions. And a few of which, if were not answered, we will get those offline. And as promised, we're going to share with you a recording of the webinar and the presentation, and hope to see you again with another yet interesting topic and engaging webinar. Thank you. Thank you, Milan. Thank you, Sergey.
Thank you, everyone.
Care,
Take care.
Bye-bye.